Hello everybody, welcome to today's lesson. Today I'm going to talk about limit. Let's do some example. We want to do some limit. X goes to 0. When x goes to 0, it becomes e to the power 0. But anything to the power 0 is 1. Therefore, the numerator is 1 minus 1, which is 0. The denominator now, when x goes to 0, it is ln 1. But ln 1 is 0 also. Therefore, we have 0 over 0. Zero over 0, you don't know what that is. So, we need to find some other way to find the limit. What is the other way? There is a law or rule. The rule is called L'Hopital's rule. This word, H has no sound, so it's pronounced L'Hopital. S has no sound as well. But if you look at some textbooks spell this way. Some textbook spells the word without S. You can find these two slightly different spellings in many textbooks. It's not mistake in pronunciation, because this person, at the beginning, his name has an S in it. At the end, his name has no S. So both spellings are right. This is what I want to mention. Okay. What is L'Hopital's rule? The rule says if you have a function it's a ratio of two functions, and if you take the limit, it goes to 0 over 0, then what you do is to do the derivative of the numerator divided by the derivative of the denominator, and then take the limit again, and hopefully you get a result, not 0 over 0. However, If you do that, you still get 0 over 0. You repeat the process until you do not get 0 over 0. And that is called L'Hopital's rule. So let's do the example. The derivative of the numerator, derivative of 1 is 0. Derivative of the exponential function is to repeat the exponential function and do the derivative of the exponent. The derivative of the numerator, the derivative of the denominator, x plus 1 goes to the numerator. The 2 goes to the denominator. The negative exponent goes to the denominator. Negative, negative becomes positive. Then do the limit again. X goes to 0, the numerator is 1. X goes to the 0, the denominator is just 2. Therefore, the answer is 1/2. So that's the answer for this limit problem. Let's do another example. Another example is very basic. You need this very, very often. This next example is the limit. This limit is very common when you do trigonometry. When x goes to 0, the numerator goes to 0. When x goes to 0, the denominator goes to 0. So it is 0 over 0. Then we use L'Hopital's rule. The derivative of sine x is cosine x. The derivative of x is 1. Then we do the limit again. X goes to 0. Cosine 0 is 1. 1 over 1 is just 1. You need to remember this. This is so important. The limit of sine x over x is 1. Okay. Next example. goes to when x goes to 0, cosine 0 is 1. So 1 minus 1 is 0. When x goes to 0, then I have 0 plus 0. So again, it is 0 over 0. So we use L'Hopital's rule. Do the derivative of the numerator. Derivative of the numerator is sine x. The derivative of the denominator is 2x plus 3. Then we do the limit again. X goes to 0. Sine 0 is 0. When x is 0 here, you have 3. Therefore, you take the limit, it is 0 over 3. Zero over 3 is 0, so the answer is 0. Let's do another example. When x goes to infinity, e to the power negative infinity means 1 over e to the power positive infinity, which is a 0. X to the negative 1, when x is infinity, but x to the negative 1 is 1 over x. So 1 over x when x goes to infinity is 0. So this is again 0 over 0. So let's do the derivative now. So what is the derivative of the numerator? You keep the exponential function and do the derivative of the exponent, which is negative 1. The denominator, you do negative 1. This is a power rule, okay, and x negative 2. So negative 1 cancel. So this is, let's simplify this. Let us not have the negative power. Let us not have the negative power. So put the negative power part to the denominator. Okay. And so I have this. So this goes up and this goes down. Now, when x goes to infinity, the numerator goes to infinity, the denominator goes to infinity. So this becomes infinity over infinity. And then I need to supplement what I said about L'Hopital's rule. L'Hopital's rule applies to 0 over 0. When you have 0 over 0, you do the derivative of numerator. Again, the same thing, do the derivative of the denominator. And after that, you do the same limit until you get an answer. But this L'Hopital rule also applies to when you have infinity over infinity. And this is exactly our case. When x goes to infinity, this is infinity, this is infinity. So we again use the L'Hopital rule. Do the derivative. The derivative of x squared is 2x. The derivative e to the x is itself. X goes to infinity, this is infinity, this is infinity. You have infinity over infinity. Again, you use L'Hopital rule. The derivative of the numerator is just 2. The derivative of the denominator is itself. Do the limit again. Then the numerator is just a constant. But the denominator, do the limit, you get infinity. So you have 2 over infinity. Which is a big 0. So that is our answer. Let's have a final example. Ln x cosine x. When x goes to 0, ln x is what? Negative infinity. Remember that? Remember the ln function? This is ln x. When x is 0, it goes to negative infinity. Cosine 0. Cosine 0 is, well, what is cosine 0? Let me see the question. Oh, no, I made a mistake. It's not cosine 0. Because it's a cosine 0, you can do it. It's cotangent 0. Cotangent x. What is cotangent 0? Cotangent 0 is infinity. Therefore, you have a negative infinity over infinity. Again, you can use the L'Hopital rule. So let's do the derivative. The derivative of ln x is 1 over x. The derivative of cotangent x is negative cosecant square x. So what is this? You can move the 1 over x to the denominator, 1 over x. And you still have the negative. Cosecant is 1 over sine. So 1 over cosecant squared is sine squared goes to the top. Okay, let's do the limit. When x goes to 0, sine 0 is 0, and the denominator is 0. So you have 0 over 0 again. So you have to apply the L'Hopital rule again. The derivative of the numerator, negative 2 sine x, and the chain rule. The numerator is just 1. Now you take the limit. Sine 0 is 0, cosine 0 is 1, so it is 0. So this question, the limit, the answer is 0. So that is just about all. We have several examples, and we apply the L'Hopital's rule. And when you get 0, 0 again, you apply the theorem again and again, until you get a good answer. Thank you for watching. This is the end of the L'Hopital rule, and I'll see you next lesson. Goodbye.